All right. Good evening, everyone, and welcome to our next video. Um, we have now completing the square in our quadratic unit. Completed, if you will, pardon the pun. Um, so now we're going to look at where we can go from here in terms of our thinking of quadratics. So this is lesson 13. All right, let's start with a little bit of a warm up here. Hey, we're getting pretty good at this whole completing the square and factoring, and we've got all these tools under our belt. Everything is going great, right? So let's pick an equation. All right, let's see what this says. Choose one equation to solve either by rewriting it in factored form or by completing the square. Psh, okay, we can handle that, right? I, huh, ooh, okay. Well, let's see. Factoring is obviously the easier of the two methods. If you know the factors, you can factor it quickly, but I, oh, none of these factor like nicely. And I mean, I suppose you could try magic number on some of these, like this one here, 44 times 5 is 220, negative 220, so they'd have to multiply to negative 220 and add to 9? Huh. Well, let's see. 220 is 11. Well, that's what, 11 times. No, it's 22. Yeah, 20 times 11. Oh, 20 times 11, right? Oh, that works. Okay, so that's 20 times 11. So I can always do this as. Now they have to add to a 9, so the bigger number. So it must be 5x plus 20 and 5x minus 11, so it must be, you got to divide the 5 back out, so x plus 4 times 5x minus 11. Okay, interesting. Um, does that work? You get the negative 44, you get a 20, you get a minus, yeah, okay, that works. And so if this equals 0, then we have x equals negative 4 and x equals 11, positive 11 divided by 5, based on all the work that we've done so far. Okay, that was lucky. But some of these other ones, I mean, 29 times 4, what is that, 116? Um, okay. Is there another one that we can quickly do? I don't know. All right. You know what we can do? Let's try completing the square. All right. Let's do one that's completing the square. Which one do you want to do? Do you want to do 1 or 4? Or, no, let's do number 1. Okay. Because it's got the middle number, it's nice and even, and that's pretty good. So let's add the 1.25 to both sides. We get x squared minus 2x equals 1.25. Now, what are we going to add? Half of negative 2 is negative 1. So we know that this is going to be x minus 1 squared. And I am going to add 1 to both sides. That becomes 2.25. Okay, so once I have that now, the square root of 2.25, well, the square root of 225 is 15. So the square root of this is 1.5. And so we are going to have the following. We're going to actually have two equations from this, right? Um, so we are going to have x, oops, select my blue again. So we are going to have x minus 1 equals 1.5, or x minus 1 equals negative 1.5. And so you're going to add the 1 to both sides, and we're going to get x equals 2.5, or x equals, we add the 1 to both sides, negative 0.5. And let's see, that's a quarter. A quarter plus 1 is 1 and a quarter. 1 and a quarter minus quarter is 0. So that does work, and that does work as well. So, oops, 0.5. Okay, so here are my two answers, and both of those answers work for that. Both of these answers work for that one. 3, hmm. Now here's the thing, that might actually factor, and I'm trying to think of, numbers like what adds to 0.375. So one thing that we can do here is you can always multiply by 8 because this is 3 over 8. And you could try multiplying by 8 and you'll get 8x squared plus 10x equals, and this will be a 3. Um, that would work, and it would actually factor if you did that. So you will get nice numbers for this one, and I suspect you'd get nice numbers for this one too. Um, to do completing the square on this one, don't forget that with questions like this, the easiest way to do completing the square is to divide out the 4. And so what you'd have is you'd have 4 parentheses x squared minus 7x plus 29 divided by 4 equals 0. Um, and you can complete the square on this polynomial, um, like with just kind of ignoring the 4 for now. You can then multiply the 4 back in. So you could do that for that if you aren't sure about how to factor that. This one you can use completing the square on it. You just cut this in half, and which is going to give you 0.625, and then you square that, and then that's the number you add to both sides. So I mean it's doable. Just these numbers are a mess. Okay, but you know the world isn't all smiles, sunshine, and integers. So of course, um, we can work these out. But I'll leave the rest to you as an exercise. The hint I'll give you for number 3, as I said before, the way that I see this, again, you can complete the square on this if you want. What I might do is multiply by 8, and then I get 8x squared plus that times 8 is 10x. And then what I'm going to do is I'm going to subtract that from both sides. I'm going to move this back over here. So I get 8x squared plus 10x minus 3 equals 0. This does factor because you can find two numbers that multiply to negative 24 and that add to 10, and that's going to be 12 and negative 2. Excuse me. So that does factor, just not very cleanly. And that's just one possibility. Okay, but remember in all of these cases, when you have numbers that don't like play nicely nice with the integers, sometimes we can apply several different methods, or really just it doesn't matter, it's going to be a mess either way. Whew, okay. This is probably about the limit of what we can hit with both factoring or completing the square. And you got to imagine, like, quadratics with these numbers do exist, right? And it's helpful to maybe have a generalized process for this. And that's what we're going to look at here. So this lesson is all about deriving what's known as the quadratic formula. The quadratic formula is, I like to kind of tongue-in-cheek a little bit, say that this is the nuclear option of quadratics. The quadratic formula is exactly that. It's a formula. Given the equation as ax squared plus bx plus c equals 0, as listed here, um, if you have an equation that's in this form, it's a formula that if you plug the numbers a, b, and c into, it will always spit out the two solutions for you, no matter how unwieldy or complex or how rational, irrational they are. They could be whole numbers, they could be fractions, they could be radicals, doesn't matter. This formula will always produce the correct intercepts. Okay, so these are the things that we're going to learn to do, okay? All right, let's get started. So let's solve these two equations by completing the square. All right, so first off, we have 2x squared plus 28x minus 30 equals 0, okay? Excuse me. Um, so remember what I said before on one of the problems that when you have a factor in front of the x squared, it's helpful if you can divide it out. In this case, all the numbers are even, so we certainly can do that. And so what I'll have is I'll have 2 parentheses x squared 14x minus 15 equals 0. Now, this does factor. I'm going to ignore that, and I'm going to complete the square on it. The reason for it, you'll see later, okay? So let's go ahead and complete the square. When I do that, okay, so this is where things get um, a little bit wonky. Um, when you complete the square on this particular one, we have this factor of 2 that's still kind of hanging out in the problem, right? Wait a second. We don't have to do anything fancy. What happens when I divide by 2? You have a 0, right? And we divide by 2, and 0 divided by 2 is just 0. So guess what? That goes away. Okay, silly me. Okay. So, hey, good thing we recognized that, huh? Otherwise, I was going to have to get fancy with some factors. No, we're not going to do that. So we have this. Let's just go ahead and complete the square now. And this will have the same answers as the original problem, simply because it equaled 0. Okay, so let's bring that over to the other side. So we have, oh, it's got that. Can I fix that? Oops. There we go. No, it's still there. How can I fix that? That's a bit annoying. Okay, whatever, we'll go with it. X squared um, plus 14x equals 15, right? What number do we add? Half of this, 7, we square it, 49 plus 49. Um, and we're going to get x plus 7 squared. And 49 plus 15, that's 64. And we're going to square root both sides, and we're going to get um, 60. We're going to take the square root of 64, so we're going to get x plus 7 equals 8, or x plus 7 equals negative 8. All right, we subtract 7 from both sides, x equals 1, or x equals negative 15. All right, easy peasy, right? Okay, same process as usual. All right, now let's try it on this one. Okay, notice the a, b, and c are numbers, and just, I mean, variables, right? And so here's the thing. A, B, and C can be any number. Decimals, they can be fractions, they can be whole numbers, positive, negative. Could be E, could be pi for all we know. Could be anything, right? Could be Christmas trees. Well, maybe not, but you get the idea. And if we can still complete the square on this, we call this the general case. And it means that since the process of completing the square has always proven to work, if it can work on this expression with all letters, that means it will work with any numbers. And if we solve this, and if we're able to solve for x, it will give us a formula on how to x relates to what a, b, and c are. As you can imagine, though, it's going to be a mess because we're not actually going to be able to perform any arithmetic. It's all going to be written as expressions. Okay, let's give it a try. First thing I'm going to do is I'm going to, over here, notice how I divided everything by 2. we're going to mimic that over here, and we're going to divide everything by a. So I'm going to try to follow the same steps. Just be careful that when I do, I'm going to get expressions that like not like simplified, right? I'm going to get like b divided by a, c divided by a, right? Okay, so when I do this, I'm going to get x squared plus b over a x plus c over a equals 0. Okay, and why 0? Because 0 divided by a is going to be 0. 0 divided by any number is 0. But all the coefficients get divided by a. X squared does not because a divided by a is just 1. That's why we divide it by a, so that this can just be a plain x squared. Okay? All right. Now, um, we're going to do what I did before. Let's move that to the other side. And that becomes a negative c over a. Okay. Now, what do I have to add to make a complete square? Over here, I added 49. Why did I add 49? Half, yeah, I know, I've said it how many times by now? Half the middle term, and then you square it. But what happens when you have a fraction? I gave you one other piece that is now very important. If you have a fraction and you need to find half of a fraction, you multiply the denominator by 2. And then, whatever that is, we can then easily square it. So over here, the term that I'm going to add is half of the middle term. And so that's going to be b over 2a because we're going to multiply the denominator by 2. And it's going to be squared. Like that. Well, that is interesting, isn't it? And guess what? Does that form a complete square? It does. And as before, what does that term end up being? It ends up being half that middle term, right? It's going to be b over 2a. So this is now, believe it or not, a perfect square. And it's going to end up being x plus b over 2a squared equals. Now what I'm going to do, I'm going to take this and I'm going to actually square it out. Minus c over a plus b squared over 4a squared. And the reason why I do that is so that I get rid of some of these messy parentheses here. And why does it turn into a 4? Because 2a times 2a gives us 4a squared. Okay? When you square, squares do distribute across multiplication and division like that. Okay, now the next thing I'm going to want to do that will also be mighty helpful to us um, is to actually combine this into a single fraction. Um, in the same way that I took those two things and I added them together, the 15 and the 49, I added them together to get a 64. These, although they are expressions, I can add them together by using a common denominator. And the common denominator here is 4a squared. So what I'm going to do is I can, and this is legitimately possible, I'm going to introduce a 4a term here and here. And so what I now have is I have in this fraction, and now I know I'm going to be extending a lot of room here. So I'll write this part again. I have x plus b over 2a squared. Okay, so what does this now equal? This equals negative 4ac over 4a squared. A times 4 times a plus b squared over 4a squared. So what I have done is I've introduced into this one single fraction a numerator and a denominator of 4a. That's legitimate without having to do that on the other side of the expression or anywhere else because it's keeping this one fraction balanced. The numerator and the denominator are both being increased the same way. So this fraction here is still the same value as the original negative c over a, just with bigger numbers. Okay, now that these two have the same denominator, I can add them together. Now, being that this one's minus, I'm actually going to take this one and put it on the right side, and now what I'm going to have is b squared minus 4ac over 4a squared, like that. Okay, we're getting somewhere. Now, all we have to do is separate off that x, right? Let's see what happens. Okay, so now that we have this, we're going to, over here, we wrote out two equations by taking the square root of both sides. Here, we're going to take the square root of both sides. Now, when we do that, keep in mind, we have no idea if this is a perfect square. Um, when you have an expression like this, you can't assume it's a perfect square. Now, 4a squared, yes, that is a perfect square. B squared, yes, that's a perfect square. 4, that's a perfect square. But a times c doesn't have to be, nor does the difference of these two things have to be a square either. Therefore, we cannot prove that this is a perfect square, and many times it won't be. So we are going to do this, and we're going to use a plus or minus sign here. However, the denominator does have a square root. And so what's the square root of 4? That's 2. And what's the square root of a squared? That's a. So I'm going to get, when I write this out, I'm going to get x plus b over 2a, but without the square. Now let's get rid of this little thing right there. Equals plus or minus the square root of b squared minus 4ac all over 2a. Um, the plus or minus for the same reason that we had before, because the square root could be positive or it could be negative. The reason why we now suddenly have 2a is because I was able to take the square root of the denominator. Okay, now here's the fun part. All we have to do is get rid of this term here. X is almost solved for. Over here, we subtracted the 7 from both sides. Here, I'm going to subtract b over 2a. Now, let's write this out. And so now we have x equals negative b over 2a plus or minus square root b squared minus 4ac all over 2a. Notice the denominators are both 2a. That's perfect, which means I can combine them together in a single expression, and I have x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. That is the quadratic formula. And that is the way that you can find the x-intercepts from standard form every single time. Um, does not matter if a, b, and c are integers, positive, negative, whole numbers, fractions, decimals, you name it. All works. Um, whether or not the expression can be simplified doesn't matter. Uh, you can always put the numbers in the calculator, right? That's the formula. The hardest part, believe it or not, is not knowing the formula. The hardest part is making sure you simplify everything properly, especially um, with the minus sign in here. This is when you have this being minus, and if A, B, and C are also negative, it's going to start to become a bit of a nightmare of positive and negative signs. And so you have to take it slow, one step at a time, and make sure you've got the correct addition or subtraction. Okay? So let's see how this formula works. Okay, one more time. Here's the formula. In now we have an exact formula, but now I showed you exactly where this formula comes from. Okay, and I can already hear some of you already say, um, hey, if there's a formula for this one where it's like an ax squared, right? And there's a formula for quadratics, and okay, which one of these math teachers misspelled the T? I do not take credit for that. Okay, um, so what happens if maybe I have a cubic where it's like ax to the third? Is there a cubic formula? The answer is yes, there is. And there's a whole conversation and a whole fun story in math about how that formula developed. Um, and yeah, oh, by the way, people died over that one. As far as I know, nobody died over the quadratic formula. Um, not that I am aware of, but this one has been known for thousands of years. So, hey, it's a pretty standard formula. Okay, so let's actually see how it works. Now, note the formula does represent two possible solutions, right? And if I were to write it out, um, you would do negative b plus root of b squared minus 4ac all over 2a and negative b minus square root of b squared minus 4ac all over 2a. In practice, what we do, the best way to be successful is to figure out the part under the radical first. And once you get that number, then in the calculator you can do, negative b plus root whatever divided by 2a, negative b minus radical of whatever that number is divided by 2a. So in practice, we find it's good to find that number first. Anyway, let's give it a try, shall we? Okay. um, okay, so here are some equations. You're probably also going to notice that many of these factor, right? Um, Definitely, I'm trying to think of the first. Yeah, A factors, B factors, D factors. C, though, hmm, 21, negative 5. C does not factor. So that's definitely one that we're going to want to do. So let's say we're going to do A and C together um, here. And then we can work out some of the other ones, right? Okay, so again, don't want to keep this video too long. Um, Once I've done two of these, the other two are going to be just the same. All right, let's give it a try, folks. All right, so my formula, and I'm just going to write it over here since I'm not going to use this part. X equals negative b plus or minus square root b squared minus 4ac over 2a. Okay, now this is really, think about this minus b as being opposite of b. Now, where do you find the a, b, and c? The a is the number called the coefficient that's in front of the x squared. B is the coefficient in front of the x, and c is the y-intercept. Now, the quadratic formula is only applied when the equation equals 0. That is a big, big deal, and that's because when we solve the original formula for quadratic formula, it had a 0 on the end. So all the numbers must be on one side for this one, okay? All right, once we know that, because otherwise, if you have a number like, if we have the 15 on the other side, you might put in C as negative 15 and get a completely different answer. All right, first things first, let's try out, let's just put everything in the formula. Okay, opposite of B. So I'm going to start with a positive 8, opposite of B. If you've got a minus sign here, it is part of the term, plus or minus, okay? square root negative 8 squared minus 4 times the value of a is 1, because there's no number there, but the x squared does exist, times 15 over 2 times 1. Okay, now in practice, you tend to not have to worry about the minus sign here because when you square it, it's always positive. Okay, that's 64. 15 times 4 is 60. And so 64 minus 60 is 4. So you're going to get 8 plus or minus the square root of 4 over 2. Now, what's the square root of 4? Well, that's 2. 8 plus or minus 2 divided by 2. Okay? So when you do this, okay, other big thing, in the calculator, if you put these in the calculator, you have to do this part in parentheses. And don't forget that you're going to do two answers. You're going to do 8 plus 2 divided by 2, and you're going to do 8 minus 2 divided by 2. All right, so 8 plus 2 is 10, divided by 2 is 5. 8 minus 2 is 6. 6 divided by 2 is 3. And so there's my two answers. I have x equals 5 and x equals 3. And what do you know? It's perfect. It works. Okay, here's a fun fact. Reason why this worked out so cleanly is because this radical was a perfect square. Fun fact, if the radical is a perfect square and comes out even, whatever even is, even if it comes out as like a decimal, say it's like the square root of 0.4, right? Which is, or like square root of 0.04, which is 0.2, right? Um, when you have something like that, um, that means that the original problem was originally factorable. Um, so whenever this works out cleanly, the original one was factorable. Whether or not you then go, oh, I should have just factored it. Doesn't matter at that point, right? At that point, you're committed. Just finish it. Okay. The same thing would happen for this one. So I can leave that for you to work on because it's going to work out pretty much the same as this one. So here's my question. What happens when you don't have a perfect square? So let's look at C. Let's do the same thing, right? Opposite of B, plus or minus, square root. Now notice here I have the minus because 5 was positive. 5 squared minus 4 times 3 times negative 7. Okay. Over 6, which is 2 times 3. All right, so this here you may consider using a calculator for. If you use a calculator for this, first off, don't put the square root sign in. Only do the part that's under the square root, especially when you believe or have reason to believe that this is not a perfect square. Um, so make sure you put the negative 7 in parentheses. That, even though it's not always necessary to do, it saves a lot of headaches with order of operations. Anytime you have a negative number, you always put it in parentheses um, in a calculator, just so that the calculator is absolutely clear as to what's negative, what's positive, and what the order of the things actually is. Anyway, uh, 12 times 7, that's 84. So this is going to be a negative 84. When you subtract a negative, it turns positive. So this is going to be 25 plus 84, and that's going to be 109. So this is going to be negative 5 plus or minus the square root of 109 over 6. Okay, can you do anything with that? No. Okay, here's the thing. This particular problem um, can't really be simplified any more than that. If you want the exact answer for x, okay, that's as simplified as it's going to get. Um, Unfortunately, we can't do because they're like 5 doesn't divide by 6. This is not a perfect square. It even doesn't have any perfect square factors that I can see. Um, Nothing like that. So um, this is done. However, if you wanted to know what the x-intercepts were, you would have to do this in the calculator. So when you do this in the calculator, just like I did above, you would have to do um, parentheses -5 plus root 109 divided by 6, -5 minus root 109 divided by 6. Okay, and get those answers. So I'm just going to go ahead and turn on my calculator. I don't know if you're able to see it or not, but I left you the nicest directions to do it. So you can accomplish that on any calculator that you wish. So on my calculator, parentheses -5 plus square root 109, oops, square root 109. Huh, okay, having some issues here. Sorry about that. 109, um, close parentheses, divided by 6. Okay, and when I do that, the first answer I get is 0.9067. Let's just round that to 0.91. I think that's good enough. So uh, x is approximately equal to 0.91. And if I do the other one, I just bring back the last command I did, and I just change the plus to a minus, and I get negative 2.57. Okay, and those are the two numbers that work. And you can go ahead and you can show that. Um, that's about it as far as the complexity goes. Um, Remember that unless you're dealing with like fractions and stuff, like the problems are all going to work out like this. This is literally the worst thing you're going to see. That's one thing that's nice about the quadratic formula is that it always works. Um, One of the big ideas, it always works. You always get the x-intercepts, even if they're the wackiest of decimals. Um, but the downside to it, and also the upside, is that the calculation is extremely consistent. So whether or not you have easy numbers, like the purple problem, or hard numbers, like the green problem, no matter what you have, the work is almost identical. And it's about the same level of complexity either way. It just depends on whether or not you can simplify down at the end. Um, so that's why I call this the nuclear option. Um, Same results every time. Problem is solved. Okay. Um, anyway, that's about it for this. I don't think I can need to go into any more than that. We just have to do a bunch of practice. But that's how you would develop the quadratic formula and a little bit on how to use it. Okay, I will talk to you guys soon. Have fun.